5.7. The ambiguous case of the law of signs. Sounds like a book. The ambiguous case of the law of signs.
Sounds like a mystery book.
Always. Now, angle, angle, side, and angle, side, angle are the ones we solved the law of signs yesterday. Then we have this one. Side, side, angle.
Which is very
Side, side, angle.
very similar to angle, side, side.
I'm not familiar with that one. The side, side, angle. In geometry, they were very clear that side, side, angle could not be used to prove congruence. And here's why. If you have side, side, angle given, you actually have three possibilities for solutions. Okay? 1, no triangle whatsoever. 2, 1 triangle. 3, 2 triangles. That is why you couldn't prove congruence, because there are different possibilities. Okay? Depending on what's given, you could have one of these occur. And the reason is because we have to use the inverse sign. Inverse sign is restricted. Okay? Only certain things can work for the inverse sign. If you have something too large, there's an error. It's an undefined situation. If it's in the right area, you get 1 triangle. If it's too small, then you have 2 possibilities. So, let's take a look at an example. Actually, I'd like to get through 2 if that's possible. Find all solutions for triangle ABC if A equals 40, B equals 50, and angle A is 51 degrees. So we have 51 degrees, side A is 40, side B is 50, and we have no idea what side C or angle C is. Now we are going to apply the law of signs. So still have sine of A over A equals sine of B over B equals sine of C over C. So we have the sine of 51 degrees over 40. That's good. The sine of B over 50, and the sine of C over C. So, what can we solve for here? B. Angle B. First, so we're going to take these two. So first multiply by 50. And here's where you take the inverse. That gives us angle B. And we're going to go ahead and put a 1 on that. Because the inverse is what's causing us to have different possible cases. So this is where we have to worry about 2 different possibilities. Let's type that in. So, inverse sine of 50 sine 51 divided by 40. Looks like 76.3 degrees, right? That's B1. Now what else? Case 2. Case 2 occurs right now. At the inverse sign, we have B1 equals 76.3. So B2 is going to be 180 minus B1. Okay? Which is how much? Correct. All right. So let's find C1. C1 is going to be 180 minus 51 minus 76.3. You go back up and look at your picture. We need to find C. We found B, right? 76.3. We need to find C. Because you have to consider two cases. What do you mean? It's always 180 minus case 1. Always going to be 180 minus whatever you find for the inverse. That is case 2. Let's look at it this way. Let's assume we don't even know case 2. Okay? Just completely forget that. Let's finish solving case 1. Let's just finish solving the triangle. Okay? Maybe this makes more sense. We have to find angle C, right? 76.3 is what we found. How are we going to find C? Subtract, just like we're doing, right? And what do we get? 52.7. Great. Once we have C, then we can find what is missing. Sine of 51 over 40. Okay. We already found angle B, right? So what we need now is sine of C over C. Or sine of what? 52.7 over side C. We can solve for side C. And just type that in. Looks like 40.943. Okay, so you follow me on that. Now, because it's a side-side angle, special case, we have to go back to the inverse. Whatever angle we find, which is in this case B, we have to consider two cases for B. B1 and B2. B2 is always 180 minus B1. Or 180 minus 76.3. So B2 is 103.7. This is case 2. So that's for our second triangle, our second possibility. Does that make sense? It gives us a complete separate answer. Why you couldn't prove congruence? Because there was two possibilities. C2 is going to be 180 minus 51 minus, instead of our 76.3, it's now going to be a 103.7. So basically you're solving the triangle again, exactly as you solved it the first time, but with a different case now. What do we get for that? more time. 25.3 degrees. Now, that's good. Now, we're going to solve this. Again, sine of 51 over 40 equals the sine. Instead of the 52.7, we're going to use the 25.3 to find for C2. Just so you know, C1 and C2 are going to be solved the exact same way. If you don't want to go through the work again, you don't have to. You can look down here and say, okay, 40 sine of, okay, here's my 25.3 over the sine of 51. And just type that in. $21.996. So I have two completely separate cases, two totally separate triangles. Okay? You have to try both cases. Now, we saw the case where they worked. Like, I'm going to do another one, show you how it doesn't work. That's okay with you. Or at least one of them doesn't work. We only get one answer. But that's the worst it could be. Do you have any questions on that? The inverse is the trick. The second case must be considered. Any questions at all so far? You ready for the next one then? I think it looks like everybody's done. Okay. Find all solutions for triangle ABC if A equals 4, B equals 3, and angle A equals 112. Same thing. Sine of A over A equals sine of B over B equals sine of C over C. So, sine of 112 over 4 equals the sine of B over 3 equals the sine of C over C. We can solve for angle B. 3 sine of 112 over 4 equals the sine of B. So the inverse sine, 3 sine of 112 over 4 equals B. It's like 44.1. Again, maybe it's easier if we just finish the first case. Just solve the whole thing before you can go back and consider case 2. That's going to be a B1 though. So what's 44.1? So we got to find angle C. 112, 44.1. C1, 180 minus 112 minus 44.1. So C1 is what? What is it? That's right. Yeah.
Let me look to see where they're at, what kind of programs they have, because I'm not sure how good they are. And can I get back to you on that, like the fourth period? Yeah, that's fine. Yep. Okay. Okay. Yep. Yeah, I'll come down for it. We'll figure it out.
All right, where are we at? What do we got to finish here? Side C, you guys already found for it probably? So, sine of 112 over 4 equals the sine of 23.9 over C. So C sine 112 equals 4 sine 23.9, or C equals 4 sine 23.9 over sine of 112. You guys already typed that in? What'd you get?
1.748.
What is it?
1.748.
That doesn't sound right. 1.7, yeah, that's right. 1.748. Okay. So we'll call that C1. All right, let's go back up and look at case 2. Here's where it starts. Case 2. B2 is going to be 180 minus B1, or 180 minus 44.1, which is how much? 135.9 degrees. Beautiful. C2 going to be 180 minus 112 minus 135.9. Right? What's that? Negative 67.9. Great. Done. As soon as you get a negative angle, you're done. That case is worthless. You see how that happens? Okay, and the no triangle possibility is when you take the inverse for the first time, you get an error. You get an error the first time you take the inverse. There's nothing to solve. You're done completely with the problem. No solution whatsoever. Do we have any questions on that?